Cryptography is such an important topic. I want to do a little more work on this. We talk about the basics in this movie, and this is excerpted from Chapter 8 in your book, so you've seen pieces of this before. Let's do some terminology. Cryptography is the science of transforming information so it is secure while being transmitted or stored. I don't really think this belongs in this chapter. Steganography is it's different. Steganography is concerned with the hiding of data. So I guess technically cryptography would be could be considered steganography. Usually we think of steganography as being something entirely different, and this book doesn't really talk too much about steganography. One example of steganography would be if you wanted to hide a document inside of like a graphics file, and this is possible, assuming the graphics file is rather large and you're in relationship to the document that you want to hide, and it's possible, and it's done many times every day, and it's detectable, but it's very, very hard to get the document out from where it's been hidden. But this chapter is not about steganography per se. Encryption is changing the original text to a secret message using cryptography. Decryption is the reverse process, reversing the encryption. Algorithm is either a process of encrypting or decrypting information, or it could be the mathematical procedure used itself. Key is the value used by an algorithm to encrypt or decrypt a message. We're going to talk quite a bit about keys. Generally, longer keys are better. And you should also make a little note that keys are numbers. So when we talk about keys, we're actually talking about numbers. A weak key is a mathematical key that creates a detectable pattern or structure, and this is not a good thing. You don't want the output of your encrypting process or algorithm to produce any sort of detectable pattern. There are actually people, very bright mathematical types in the world that analyze encrypted information looking for these patterns. You could, another name for these type of people are code breakers, or cryptanalyst. So you don't want patterns in your output. Plain text is whatever you start with, the original unencrypted information. So, and it doesn't have to be text. It could be documents in any kind of format, any kind of data in any kind of format. Could be graphics files. It's just whatever you start with. Cipher is the encryption or decryption algorithm used to create the encrypted or decrypted text. Sometimes you see this word used. Sometimes they just refer to the algorithm itself. Ciphertext is the data that has been encrypted by an encryption algorithm. Now, here we have a graphic, and this comes from your book. The first thing you need to remember here is the flow here is kind of been folded back on itself. So it will fit on this one slide. So we have a sender. We have some sort of plain text here. We're going to feed it into the cipher. This would be the algorithm that we're going to use. key here, remember, key is a number. So we feed in the plain text into the cipher, we feed the key in, and the output of this is a mathematical combination of these of the plain text and the key, and it's the ciphertext. And again, you want your ciphertext to have no discernible patterns. Ciphertext can be sent across a public network to the recipient. So here we have the same ciphertext that we start out with. We feed the ciphertext back into a cipher on the receiving end. Again, we have to input a key. The key is sometimes the same on each end. Sometimes it's not. So whatever key we have to put in here, the output of this should be exactly equivalent to the original plain text. So this is what we're talking about when we're talking about cryptography and plain text and ciphers and algorithms and ciphertext and keys. This is the big picture here, and we're going to go into more detail as to what really goes on in certain situations in this process. How does cryptography protect our information? And there's actually a couple of slides on this because it's important. Cryptography is intended to protect the confidentiality of the information. Make sure that only people who need to or should see the information actually can see the information in a form they can make any sense out of. Second function of cryptography is authentication. Now, you might want to make a little note here. You don't necessarily have to have all of these at the same time in any particular application. Sometimes you do, sometimes you don't. Authentication is gives you a mechanism to prove that the data came from where you think it came from. And if you think about this, this is a pretty big deal. Cryptography should also ensure the integrity of the information, and this means that the information hasn't been changed from the time it left the sender till it reaches the recipient. There's been no change in the information. Cryptography should also be able to enforce non-repudiation. Non-repudiation is basically means that the sender cannot deny that he sent the text. So if you think about this, this is also an interesting concept. And the book points out that cryptography can also be used for access control. That's not one of the bigger issues with cryptography, at least in my mind. So this is important enough that I put another slide in here. This is my slide to expand on this a little bit. So this is the way I remember this. I remember Cain. Confidentiality. The encrypted message cannot be read or decrypted by those not meant to see the message contents. And I think that's pretty obvious. Authentication. The source of the encrypted message can be verified. You don't have to have authentication, but it's kind of interesting use of encryption. We'll talk about later when we talk about digital signatures. Integrity means the contents of the encrypted message have not been modified, and this can be verified. And again, non-repudiation, this the sender of the encrypted message cannot deny sending the message. So this is the basics of cryptography. We've looked at some terminology, and we looked at the basic concept of encrypting a message and then decrypting a message. And we've talked about the reasons that we want to use cryptography. And I'm going to expand on several of these concepts in in later movies.